Hello everyone. My name is Dr. Soumaya Khlifi, and I'm happy to welcome you to this class. Just to have few line about me. I'm from France, and my background is in chemistry and material science. I am specialized in the design of functional material, especially systems that combine the chemistry and the physics. So our class today is about thermodynamics, and is at the very heart of what I do. So I have worked both in research and in teaching, and what I enjoy most is helping students to connect theory with real and everyday phenomena. So I hope we will learn a lot together. So before we begin, I would like to talk a bit about you. So could you please tell me your name, where are you from, and maybe one thing that you like, or even one thing that you find challenging about studying chemistry or material science? Maybe this will help me to understand your background and make the course more connected to your interest. So this is the time for the student to introduce themselves. So now we are continuing. So in this class, I want us to create an environment built on the trust, on the respect of each other, and on collaboration. So we are here to learn together, to support each other. Okay, I'm the teacher, you are the student, but somehow I'm also learning something from you. So we need to support each other, to ask a question freely, and to grow as a team. We are a team. So our class contract, we can say, it's simple for me. It's about listening, participating, and helping each other. So let me now maybe briefly explain how I would like to organize the course. So each session will be including a short lecture where I introduce the key concepts, followed by an exercise or discussion part where we can apply what we have learned. And the assessment will be based on the participation, of course, this kind of small discussion we have, small assignment, and one main evaluation at the end. Something that I really like to do also is I will also provide you with a summary sheet or a memento after each lecture. This will highlight the most important formula and ideas about the course, and somehow something that can help you to use and prepare for future topics. Finally, I will create a reflective journal or a note in the classroom. You can use it anytime to write short comments, maybe about something that you are not, something that is not clear for you, a concept that you would like to discuss more, or any personal difficulties you are facing. And I will read all the notes and do my best to adapt my teaching or meet with you if you need any personalized help. So you can also leave positive feedback or ideas. It's a space for open communication for everyone. So now let's move to the today's topic. So thermodynamics. I know that mainly students they hate this course, but you will see it's very easy and very interesting. So we will talk about thermodynamics, and specifically today I will describe the Gibbs equation that connect the three very important ideas. Something called enthalpy, entropy, and temperature. Enthalpy is usually represented by delta H. Entropy is represented by delta S, and temperature, which is T. So in simple terms, Gibbs free energy tell us whether a process or a reaction will happen spontaneously or not. Maybe these terms are very abstract for you. So let's talk about it. Let's explain what is it. So think of entropy as the measure of disorder or randomness in a system. To visualize it, imagine you are entering a crowded room where everyone is standing, moving, and talking. It's really chaotic. That's high entropy. Now imagine the same room but everyone is seated quietly and organized, and it's easier to find someone or something, and that's what we call lower entropy. So systems in nature, they tend to move toward higher entropy, to the calm, to more disorder, because there are more possible ways for things to be disordered than ordered. Enthalpy, on the other hand, is the measure of energy stored or released in a system, like heat. So the Gibbs equation that I'm talking since the beginning about is delta G, the Gibbs free energy, equal delta H, the enthalpy, minus temperature multiplied by the entropy delta S. This will help us to understand whether a reaction will occur spontaneously or not. So I will give you a real life example. When ice melt or you are having an ice cream at a room temperature, it will absorb the heat. So it's positive enthalpy. Delta H is positive. But the system become more disordered and the entropy will increase. At a certain temperature, the increase in entropy is large enough that the temperature multiplied by delta S become greater, higher than delta H, making the delta G negative. And that's why ice melts spontaneously at temperature above 0 degrees Celsius. So thermodynamics is everywhere. When you boil water, when your phone heats up, when living organisms use energy, it's all governed by this same principle. So this is a short introduction, but in our class, we will look deeper into how energy transformations shape chemical and physical processes. And remember, this classroom is your space. So you are free to feel free to ask questions, share your thoughts. If you have any comments or something that you would like to share, and you can use, of course, the reflective journal anytime, and you can talk to me or find me also. So thank you, and I'm really looking forward to learning and exploring with you this semester. Thank you very much.